So to understand Git, we need to understand what the SHA1 hash is. The concept here is that any file on the computer, you can think of it as a series of bytes. If you put those bytes from left to right, you can think of every computer file as actually a very large number. There's an interesting function called SHA1. If you click this link, you can look at the actual definition by the Internet Engineering Task Force, the IETF. And it's the following really curious property. Basically, any binary number up to 2 to the 64th bits, which is a really big number, can be rapidly mapped to a 160-bit number that we can visualize as 40-character long number in hexadecimal, which is base 16 format. The numbers add up because one hex character is 2 to the 4th or 16 values or 4 bits, so 40 hex characters is 160 bits. And here's an example of doing this in Node. So you do require crypto. You take the built-in crypto library. And this is the kind of invocation. You're creating a SHA1 hash function. And you're passing it in this data, hello world, period. And you're saying that data is ASCII formatted. And you're doing a digest, a hex digest, to output it as hexadecimal. And this is what a SHA1 hash looks like. It's a 40-character long string of hexadecimal digits. The important thing about SHA is that it behaves very differently from most normal functions like cosine or exponential, for which you can expect continuity. To understand this, essentially, if you've got two numbers that are unequal over here, it's very unlikely that their SHAs are going to also be, or rather, it's very likely that their SHAs are not equal. So inequality of two numbers means it's very likely that their SHAs are also not equal. And to understand what this means is it's also got another property, which is that deformations or perturbations to the output behave very differently for SHA than they do for normal function. So here's normal function. Let's define x as pi over 8 and dx as pi over 128. Notice we're using the math library that's built into JavaScript. And if we calculate the just the cosine of x, okay, that gives us this value. Cosine of x plus dx or x minus dx, and it gives us values that are very close to the initial value of 0.923. Okay, but SHA, by contrast, is quite different. Even small perturbations to the hello world string result in completely different SHA1 values. So here, for example, we're defining a function as SHA1, so we don't have to type it in over and over again. And notice if we add a space to the end of hello world, we get a completely different string out. The hex digest is totally different. If we subtract a period, again, totally different. If we put a space at the beginning, again, totally different. And so in this manner, if you've got two strings that are different from each other, their outputs, their SHA1s, are also very, very likely to be different from each other. And that's really the property of a good hash function. So the main thing to keep in mind, though, is for the purposes of Git, rather than carting around an entire file or looking at this multi-megabyte file to determine if it's equal to another file, all you need is the SHA1 hash of the file. And if the two SHA1 hashes are unequal, then whether this is 1 bit off or 1 byte off from each other or a million bytes off, if this was an MP3 file and these were different from each other, you'd know almost certainly that they're different files. And so in this manner, you can use the SHA1 hash as sort of a unique key for a file or really any arrangement of bytes. And that's a property that Git will use, and this is kind of what SHA1 is.